Hi everyone. Today we start integration. This integration is under what we call calculus. Yeah, calculus is divided into two major parts. We have differentiation, we have integration. And differentiation, we have applications, and of course, integration again, we have applications. So we can see this is the first lesson for integration. So these are just basic cases of integration. Yeah. Integration, first of all, we have a stretched S. This S basically it's about sum. Yeah, so it would have been like S. Yeah, but this S is stretched. So we can see like elongated S. So this S is what we mean by the integral here. Okay. So the integral symbol, this one, once you see this one, it means integration. It means you are in the world of calculus. And in calculus, you are in the case of what? Integration. Once you see this one, just like if you see dy dx, it means you are in calculus, specifically differentiation. If you see this symbol, it means calculus, specifically integration. Okay. Now let us observe something here. Y is equal to x cubed minus 3x plus 4. I just want to explain a scenario. Now, we have a function y equal to x cubed minus 3x. Okay, let me just make it a complete one. Okay. Now, not integration, in differentiation, if we want to differentiate y with respect to x, this power multiplies the coefficients. 3 times 1 is 3. Then the power minus 1 gives us 2. Minus. If we want to differentiate this, 2 times 3 is 6. The power minus 1 is 1 because 2 minus 1 is 1. So no need to write 1. Plus, the power here is 1. 1 times 4 is 4. But when we take 1 from this power, there will remain 0. So x to the power 0 is what? Is 1. 1 times 4 is 4. You differentiate 4x is 4. You differentiate 3x squared is this one. This is this one. When you differentiate any value that does not contain this, we get 0. No need to write 0. Okay. Now today, we want to understand integration. Now, first of all, let me inform you that integration is what? It's like what to say anti. It's the opposite. It's the reverse of differentiation. Okay. Now, if we want to take this back to this, we integrate. From this to this, we differentiate. What do? We can give this 1. When we give this 1, dy times 1 is dy. And the x times this is 3x squared minus 6x plus 4 dx. Remember, we cross multiply dy times 1 dy. This times this is this dx. So first of all, that is why always when you are integrating, you will see dx, dx, dx. You see, dx telling you that this result you see once it was once what a function that was differentiated now to be integrated to take it back to where it was. That's why when we are integrating a function, you will see dx. Because this a is a function of t, we say dt, acceleration. This one is a function of t, dt, 2 pi r. Yeah, the variable is the radius, so we say dr, something like that. Okay, so now if you bring in the integral, so it's like you are integrating a derivative of y that was once a function in terms of x. So the reason we get this one. So if you integrate this, it will take you back to this. Well, before I do it, let's just start from the simplest cases. Okay. Now, we want to integrate x. How do we integrate? Generally, if you have x to the power n, you want to integrate it. What do? You add 1 to the power. So we say x n plus 1. You add 1 to the power. Then the new power you have is what you bring down, n plus 1. This is integration for you. Okay, so if you want to integrate this one again, ask yourself, what is the power? The power is 1. So we say the power is 1. But according to integration, we always add 1 to the power. We add 1 to the power. Then the next question is, what is the new power? 1 plus 2. 1 plus 1 is 2. The new power is 2. So we have x squared over 2. But there is something I want to explain. Let us go to what I was explaining here. Now we differentiated this to take us to this. We want to integrate this to get us to where we came from. What do? Now we say 3x. To integrate, you add 1 to the power. So 2 plus 1 is 3. You divide by the new power. The new power is 3. Minus, we have 6x. What is the power here? Is 1. But we are integrating, so we add 1 to that power. Adding 1 to this one gives us 2. The new power is no longer 1. The new power is 2. So we'll bring down 2 plus. This for when you are integrating a constant. How do we know it's a constant? It does not contain this letter attached to D. So integrating a constant, just give it that letter. So now let us observe, this takes away this. We are left with x cubed. Look at x cubed. 2 into 6 is 3. Look at minus 3x squared. Then 4x, look at 4x. How about this 3? This 3, we cannot attain it anymore. We cannot get it again. So because we cannot get it again, so we're supposed to create a recognition that there is something that we cannot retrieve. There is something that we cannot get back. Despite all these terms, we are able to get them, but there is a term that we cannot get again. That is why whenever you integrate, you're supposed to say plus c. That plus c in a typical way is like a recognition that there is a value that we cannot attain. But there is a condition for this c. You can only add that c provided if you are integrating an open function like this, there are no limits. In integration, sometimes we have numbers like 1, 3. For example, we can say from 1 to 3. So these are limits. In practicals, these are boundaries. Yeah, from the beginning to the end, these are boundaries. So, when we talk about boundary, it's like when we say limit. In a room, if you keep walking, once you get to the wall, you cannot walk further. Yes. If you are coming from somewhere, you have a limit. So the reason we call them limits, they are boundaries actually. Okay. But if you are differentiating without limit, you're supposed to say plus c. That is why without limit, we call this one indefinite integrals. They are indefinite. Yes, because no limits. But if there are limits, there are numbers here, we call it what? Definite integrals. Okay, so we say plus c. Now, because of that, integrating x, the power is 1. This one, we add 1 to it. This one is what we have, plus 1. Then we divide by the new power. 1 plus 1 is 2. Is the new power. Then don't forget plus c. I just explained why we always say plus c. No numbers here, no limits here, so we say plus c. So therefore, x squared over 2 plus c. This is integration. Basically, we have x squared. The power is 2. To integrate, we add 1 to the power. We divide by the new power. 2 plus 1 is 3 plus c. So x to the power 2 plus 1 is 3 over 3 plus c. Why adding plus 1 is because when we are bringing this function by differentiating, we always say minus 1. You see, 3 times 1 is 3, then x raised to 3 minus 1 is 2. So that minus, we minus to get it to a derivative, taking it back to where it was, the reason we also add 1, the reason you are seeing plus 1. Here we say 4x. If you add 1 to 3, we get 4. What is our new power? It's 4. Then we say plus c. This takes away this. So we say x to the power 4 plus c. This is what we get. Here again. But here, 4 is a constant. How do we know that 4 is a constant? Because it does not contain this letter that is attached to d. That makes it a constant. Integrating a constant, simply give it this letter. So you say 4x. Do not forget c. As far as mathematics is concerned, you don't indicate c, it means it is wrong, because this one is what? An indefinite integral. So we continue. 2x minus 1. Okay, 2x. What is the power here? It's 1. If you add 1 to that one, we get 2. The new power is 2. You divide it by that power. 1 does not contain this x. That makes it a constant. Integrating a constant, give it this letter. So we say 1x plus c. So this takes away this. X squared minus x plus c. This c is what we call the arbitrary constant. We call it arbitrary constant. X squared. If you add 1 to this, we get 3. Divide by the new power. Minus 3x. If you add 1 to this one, we get 2. We divide by that new power. Plus c. Do not forget plus c. If there are limits like from 0 to 3, we don't have plus c. Okay. So we have fraction here. To do this, let this one go. Let us take it first to the top. So we say x to the power minus 2 dx. Okay. Now to integrate, what do? We add 1 to the power. I hope there is minus 2. So if we add 1 to it, divide by the new power. What is the new power? Minus 2 plus 1 is minus 1 plus c. Why we don't add plus c here? Because we have not integrated here. We only rearrange it to become like this. So this is now equal to plus divided by minus x raised to minus 1 plus c. Yeah, you can also write it as a fraction as minus 1 over x plus c. No problem. So this one is 2 pi r. Yeah, circumference of a circle, 2 pi r. So now we want to integrate it. But ask yourself, what is the variable here? The variable is r. Pi is a constant. Okay. So if the variable is r, we only deal with the power of r. So we say 2 pi r. What is the power of r? Is 1. If we add 1 to this, what do we get? We get 2. Then we divide by the new power. Let us don't forget plus c. So this takes away this. So we get pi r squared plus c. So whenever you integrate circumference of a circle, you get area of a circle. When you differentiate area of a circle, you get circumference of a circle. This is the acceleration a. Yeah. So in terms of t. So integrating this, what do we get? We say at. Remember what I said here. This value does not contain what is attached with with d, which is x. That makes it a constant. Integrating a constant, give it this letter. This a does not contain t. It's just a. Yeah. Integrating this, we give it this. So plus c. Okay. U plus at. u plus at, one of the equations of motion. U is a constant. How do we know? Because it does not contain this t. How do we know 4 is a constant? It does not contain x. So integrating it will give it x. How do we know a is a constant? It does not contain t. Integrating it will give it t. How do we know u is a constant? It does not contain t. Integrating it will give it this letter. So we say ut. The variable is t. So we say at. How do we integrate it? We add 1 to the power. There is 1 already. Adding 1 to it will make it 2. Divide by that new power. So therefore, ut plus, there is 1 here, half at squared, then plus c. So this is the first class for integration. I hope you like it, you enjoy it. So don't forget to share, like, follow, and comment. See you in my next video.